Okay, here is another question. A body drops into a well, that is questions in falling bodies, dropped into a well, hits the water surface in 6 seconds. How deep is the well? And with what velocity the ball hits the water surface? So there are two questions here. How deep is the well, which means the height, and with what velocity did the ball hit the surface? So these are the two parameters that we're looking at. So from here, we want to make an assumption that the height of the well is actually the surface of the water, that is the point at which the ball touches the surface of the water. So that's what we will assume to be the height of the well, because that is the limited information we have here. So we're going to be writing and going through a body falling down because the body is being dropped. And what did we say about the value of U when a body is falling down? U becomes 0. What about the V? The V can be calculated or computed. So I'm going to put a question mark. And the G is actually 10 meters per second square, which is positive. In other words, we have a positive of 10 meters per second. So now we have 10 meters per second positive. Now it's time for us to see which formula is going to fit this. So what we need is the height. So we're going to place a question mark also. So we need the velocity, we need the height. So let's look at our equations of motion. Quickly, V is equal to U plus AT. V squared is equal to U squared plus 2AX, and X is equal to UT plus half AT squared. Then we also have X is equal to V plus U over 2 bracket T. This was where we started from. These four equations of motions, you have to have it at the back of your mind. So the first thing we have to do is to calculate the velocity at which it hits the surface. So from that, in this case, you might be asking, what is the value of H? H also represents S, and A also represents G, right? So we can fix all that there. So in other words, you can say 2GH in this case, right? So which formula are we going to be making use of? We're going to make use of the second one because it has all the parameters we needed. V squared equal to U squared plus 2GH, which is 2AX. So 2GH. Now, we said the V squared initial velocity is 0, so we place 0. 0 squared is still 0. 2 times 10, then times multiply by the height at which it is falling from. Do anybody know the height? Yes. Nobody knows the height. So that's another question. And we were told the time that it takes. So the time it takes is actually 6 seconds. So from the look of things, this is not going to work because we end up looking for two parameters at the same time. So let's try this other formula. And that says that V is equal to U plus AT. So let's see that V, the initial velocity is 0, the acceleration due to gravity 10, and it was falling for how many seconds? We are told the time it takes to hit the floor is 6 seconds. So I never wrote that out. That's T is equal to 6 seconds. So we have 6. So we have V is equal to this. So if you multiply this, you're going to get 60 meters per second. So we've gotten the velocity at which the ball hits the surface. Now, the next thing we have to calculate is actually the height at which the ball. So in this case now, we can then make use of this because we've already gotten the value of our height. So we use the V squared is equal to U squared plus 2GH. So V squared is already known, which is 60. So that's 60 squared equal to the initial velocity 0. The body is falling down 2 times 10, then times the height. So in this case, we're going to have 3,600. So 3,600 equal to 20H. So we know how to take care of that. So 3,600 over 20. And then 10, we cancel out 10. And I don't have my calculator with me. So this will give us 180. 180. So it takes 180. It takes 60 meters per second for it to hit the floor. And the height at which it's falling from is 180 meters.